Hi everyone, this is going to be a second video of SQL Interview Question series. And today we are going to discuss about one question which is related to employee table. Let's consider we have this employee dataset where we have employee ID, his first name, his last name, and his manager ID. Here, if you will see the values of manager ID, you should notice that this manager ID is coming from this employee ID itself. Or I should say that manager ID is a subset of employee ID. Now let's try to understand it. Let's take an example of third record, where we have employee ID 3, and that person name is Michael Johnson. His manager ID is 1. Now, if we want to know the name of that manager, we have to backtrack it, and we need to see who is that person whose employee ID is 1. When we will check it, then we will see that that person name is John Doe. That means John Doe is a manager of Michael Johnson. So now what we need to find out is, we need to find out the name of that manager who have the most number of employees working under him or her. If we will manually trace this, then we can see that manager who is having an ID equal to 1, 2, and 3, they all are having 2 employees working under them. But if we will notice, the manager who is having ID equal to 4, he or she have 3 employees working under him or her. Now, if we will backtrack again, who is that person or who is that manager who is having ID equal to 4, then we will be able to know that Emily Williams is a person who is having maximum number of employees working under her. And those employees are Jessica, William, and Sanjay. So our answer is Emily Williams. And we also need to print the count of employees who are working under her. So the answer should be Emily Williams and 3. Now, by this time, you should have understood that this question can only be solved via self-join. Now, the next question is, what is self-join? So whenever you join your table with itself, we call that particular join as self-join. Here we need to understand that in SQL, we do not have any word, something like that, or any keyword with the name as self-join. It doesn't matter what kind of a join you are using, whether it is an inner join, a cross join, or left outer join, or right outer join, whatever join you are using. If the table is getting joined by itself, we call it a self-join. All right. So when we do the self-join with itself, in that case, it becomes mandatory to provide an alias to our table, right? Because otherwise you will not be able to understand one particular column is coming from which table. That's why in order to make a distinction, you have to have provide an alias to the table. Now let's go to the OneNote and let's try to picturize it. So here we have employee table in the left-hand side, and again we have employee table in the right-hand side. We will call the left-hand side table as E1 and right-hand side table as a E2. Now we need to do a self-join, and self-join is nothing but another type of a join. And you know that whenever we need to do a join, we need to do a join on the basis of a common key. Here, most of the people do the mistake. What they do is, they think like, in both of these two tables, employee ID looks like a common primary key, and they think that these should be the joining keys. Now we're going to see that if we will take employee ID as a joining key, what mistake are we going to do? So what we are doing over here, I'm printing all the columns from E1 and E2, and between them, I'm just printing one hard-coded column so that we should know that on the left-hand side, we have E1 column, and on the right-hand side, we have E2 column. Then we are doing a join between E1 and E2. This time we are taking it as inner join. And then we are doing join on the basis of employee ID. Let's try to see if we will do the join on the basis of these columns, what will the consequences we will see. So here you will see that we had 11 rows, and as an output again, we are getting 11 rows. If you will closely analyze it, you will be able to notice that the first record of E1 table got joined with the first record of E2 table. And from this data set, I'm not at all getting any meaningful information. I'm nowhere closer to solve my question. That means we have done a mistake by choosing employee ID as a joining key. Now, you remember that logic that whenever we need to find out the manager detail, we need to do a backtrace. So what we're going to do is, this manager ID we're going to use, and we're going to do a backtrace with the employee ID of E2 table. So manager ID of E1 will get joined with the employee ID of E2, right? So whenever I want to know the information about manager ID 2, I need to check employee ID equal to 2, and then I will know Jane Smith is that person who is a boss of or a manager of Emily Williams. All right. So this time we're going to use manager ID from E1 and employee ID from E2 as a joining key. Okay. Let's see what output we're going to get this time. Here you can see manager ID is getting matched with employee ID. I have already told you that I have created this column just to make a differentiation between E1 and E2, so don't get confused. This is just a hard-coded column. Now, here we can see that at least now we are getting some meaningful information in a way that now we know John Doe is a manager of Jane Smith and Mitchell Johnson. Not Mitchell, it's Michael Johnson. My bad. And similarly, Jane Smith is a manager of Emily Williams and Robert Brown, right? Remember, we should not use inner join over here. If we will use an inner join instead of a left join, then let's try to see what will be the output. Here you should notice that we had 11 rows, but as an output, we have only received 10 rows. Why it happened? It happened because we have used inner join. If you will closely have a look into these two tables, you will analyze that for the first record, manager ID is equal to null. And as you know that null is a non-comparable value. That means this null will not get any matching records or matching value in the corresponding E2 table. And that's why it got filtered out while doing an inner join. But we do not want to filter it out, and that's why we're going to use left join. Let me again run it. And here you can see that for the first record, because we were not having any matching record in the E2 table, that's why for each and every column of E2 table, null value got printed out. All right. So this thing I have already discussed, that null value is not even equal to itself. Okay. Okay. So what we're going to do is, now we have some unnecessary columns over here. Let's get rid of them and only print those columns which are required. So what I'm going to do is, I'm going to print first name and last name from E1 table, and then first name and last name from E2 table. So this is what I'm doing over here. Let's run this query. This is again the same query, only the columns we are filtering out. All right, so we are somewhat closer to solve our questions now. But let's concatenate first name and last name so that it will give us a better picture. So what we're going to do over here is, we are going to concatenate the first name with the last name with having a space between them. So this I'm going to do for E1 table also, and even for E2 table. Okay, let's do that. All right, so now we have employee name and manager name. So E1 table was having all the employee name information, and E2 table was having all the manager name information. Okay, you can treat it something like that, even though they both are the same table, but somewhat we have simulated them in a way that E1 is behaving like an employee table, having an information of an employee table, and E2 is behaving like it is having a information of manager table. Don't get confused on this. Stay with me. All right. So now what we're going to do is, we are going to identify, or we are going to calculate the head count, employee head count under each and every manager, right? So what we will do in this case, we will take that upper query which we have run over here, and we will make it as a subquery. And on top of it, we're going to have an outer query where what we're going to do is, we are going to do a group by with the manager name. And then we will also calculate how many rows we have in that group. For example, a group of John Doe has 2 records. A group of Emily Williams have 3 records. So this is what we are going to print. We are going to do a group by on top of manager name. And then we are going to print that manager name. And we are going to count the occurrence of that particular manager. Basically, here you can use count of 1. Here you can use count of employee name. And here you can use count of manager name also. Every possible combination will give you the same result set, right? Here also I'm doing one thing. For manager name where we have value equal to null, I'm making sure that I'm replacing that null value with a string, constant string, not reporting to any manager. Okay. So in order to do that, I'm using a coalesce. As you already know, coalesce what does is, whenever it finds out any null value, it will replace that null value with the value which we provide in the right hand side of it. Okay. So let's try to run this query and see the output. All right, so now we have all the manager names and the employee head count corresponding to them. As we already can see that Emily Williams is that person who is having the maximum number. Now the only thing is to write a query in such a way that we select only Emily Williams. So what I'm going to do is, now I'm going to create a CTE on top of this query. I will use this query and I will create it as a CTE. So what I'm doing, I have written the same query over here and created as a CTE. Now, why I have created it as a CTE, we will know it. Now, what I'm going to do is, I'm going to do a select star from the CTE, but after that, I have one filter condition that I'm going to print only that record where the employee head count is equal to, basically, I can keep it like equal to also over here. That will make more sense. When the employee head count is equal to maximum of employee head count from the same CTE. I think it will be better if we can keep in over here. In will be helpful in that scenario where 2 people will share the same employee head count. Okay. I think you should be able to understand this. This is a very simple query. Now let's try to run it. Now this is our final query, guys. Whatever queries I have written earlier, those I have written just to explain you. And now this is our final query. Let me show it to you in a single page. So we have the CTE. Here I have already explained you the working of a query. And we have taken that final query and we have utilized it so that I can filter out that employee who is having the maximum number of employee working under. Let's try to run this query now. And here we have the outcome. So Emily Williams is a person having the maximum number of employees working under her. I created this video to explain you the concept of self-join. Try to solve some other example of self-join and educate yourself. That's it for this video, guys. I'll meet you in the next video. Till then, take care. Happy learning. Bye-bye.